Let's go through the concept of differential equation in this question. So what is the idea of a differential equation? The notion is that the result that we're getting is not going to be just a value, but is going to be a function. So differential equation. For instance, remember before, if we had the equation of something like that, x squared minus 4x plus 8 equals to 0, for instance. That's a quadratic equation, so we can find out two x values. So we'd actually have two numbers as our result. But in our case, we have an equation where the result is going to be a function. We're going to have y equals to something depending on x. So let's see how that works out. We have the equation here, and we can see that we have the derivative of y with respect to x. So let's try and find out what is the derivative of y with respect to x only. If we take 12 on the other side, we would have minus 8x times the derivative of y with respect to x equals to 4x minus 12. Now let's keep dy dx on one side, so we would divide by minus 8x. We would divide the other side by minus 8x, so we'd have 4x minus 12 divided by minus 8x. Now what is 4x minus 12 divided by minus 8x? Well, that's just 4x divided by minus 8x and minus 12 divided by minus 8x. We would deconstruct our upper side, our numerator is equal to 4x divided by minus 8x and then minus 12 divided by minus 8x. So what is 4 and minus 8? We cancel out the 4 with the minus 8 and we're left with minus 2. X and x goes away, and here 12 and minus 8 also cancels out because we can cancel out by 4, and we're left here with 3 and here with minus 2. So the derivative of y with respect to x would equal to minus 1 over 2 from this term, and then minus 3 over 2x. Minus and minus converts into a plus, so we have plus 3 over 2x, and that would be the derivative. Now look, this is the derivative. How can we find out our y value? Because we know that the result should be a function, so that would be y depending on x. To go from the derivative to the original function, remember we're using the antiderivative, or as we call it, the integral. So if we have dy divided by dx, and that's equal to minus 1 over 2 plus 3 over 2x. To calculate the integral, we would take the integral of both sides. So we take the integral over here and then apply the dx, and we take the integral on the other side as well and apply the dx. So what is the integral of dy dx? That would be just y from here equals to, what is the integral of minus 1 over 2? That's minus 1 over 2x plus, what is the result over here? Well, that's the integral of 3 over 2 times 1 over x. That's the same as 3 over 2 times 1 over x. We know that we can keep the constant, and what is the integral of 1 over x? That's ln of x plus a constant, right? That's always what we write in the end. Now this, what we call, is the general solution, because it's a function of y depending on x, as we said, but it's with this, with any constant in the end, so it's general. We can put any value for c. Now how can we find something more specific, something particular? Well, let's go back to the beginning of the question, and we can see that here, when x is 1, y is equal to 6. So let's apply this. If x is 1 and y is equal to 6, then we can substitute 6 into y equals to minus 2 times x equals to 1 plus 3 over 2 times ln of 1 plus the constant. Okay, let's do the math. We have 6 equals to minus 1 over 2 plus ln of 1 is just 0, so that's going to be 0 plus the constant, which means that the constant is going to be equal to 6 plus 1 over 2, which is 6.5 if we write it more mathematically. Now the constant is 6.5. If we substitute it into our general function, it becomes a particular solution. So now we can say that the y value is equal to minus 1 over 2 times x plus 3 over 2 ln of x plus 6.5. And now it's not any constant in our equation, but in our function, but it's just the specific value of 6.5, and we call this our particular solution. And that's it, we are done.